All right, class, let's go with it here. We are about to start the recording process. I'm going to go back real quick here. We're doing 7.6 linear programming is what we have. And we have this little piece right here. We have a region, and you guys can pretend that you have this right here. There's just lines coming out, right? These are lines that we've drawn. This is one line. This is a second line. Let's make that a straight line. Let's say another line went like this. Another line went like this, a whole bunch of them here. We are going to graph more than 3 now today. Yeah, eventually all that crosses, right? And so you got this little inequality that has this little region here. And a computer scientist figured this out a while back, saying that if you want to minimize something or maximize something, it's never going to happen in the middle of this region. It's always going to happen on the corners here whenever you're trying to minimize or maximize something. So all we got to do is really got to test the corners to figure out what would maximize that something, what would minimize something. I used to teach the business math class, which did this right here. Well, a project in the class was we were raising chickens and we were raising pigs. That was the problem. So we had a whole farm. The students actually had to go and figure out feed cost per day. Right? We raised them for 30 days and then we sold them for profit. And so this was exactly what we're doing. So the question is this: knowing the numbers from last season, can we figure out what would be our reasonable profit margins? And how many of each should we do to maximize profit? So how many, let's say chickens, how many chickens and how many pigs to actually maximize? Because we have what? We have feed. We also have land, right? Is there a land component to it? Because we don't have so much land that we can put in, right? We have how much we need to take care of them, distribution back to market, right? We have all those different pieces there. And eventually, like, oh yeah, it worked. If we're looking at last season's stuff, this would probably be the best ratio. So go from there. Okay, example 1. Here's what we need to do. We need to maximize. I'll just put max. We're going to maximize this equation right here. Z is equal to 3x plus 2y. So what does that kind of mean? X is worth three times something for us. Y is worth 2. So if we're talking about pigs and chickens, so the pigs are worth $3 for us for profit. Pigs are worth $3. Chickens are worth $2 for profit. So this is our profit equation right here. What are the conditions? Conditions is it would be kind of dumb to raise -4 chickens. So we're probably going to raise 0 chickens or more. Plus also, we can't raise -4 pigs. So that has to be in there.
Wait, what did you say? Like there are times 3 more, times 2 more in association too. So like
yeah. So if this is good question here. So this is a profit for us, right? My pigs are worth $3 to me for profit.
Yeah.
Right. As opposed to chickens, I can do more of them. They take less land space and they take less feed, but then they're not as profitable at the end. So I have to compensate for both of those. Okay, and the relationship. Maybe this would be the feed relationship over here, or the land relationship, whatever it is. But here's the next relationship. X plus 2y is less than or equal to 4. So 4 is all I can do. I can't do more than 4 tons of feed per week, I guess, whatever it is. And then I got a relationship here, the land relationship. If I give so much land to X, Y has so much land to give. But I'm stuck. I only have 1 parcel of land to give to this. Let's go for it. So first things first, we do need to graph these guys. More importantly, when you guys graph it, your graphs have to be good. I see a lot of you guys with quadrule paper. So this isn't gonna be too crazy here, but you do have to figure out where those intersection points are going to be. We're good. So if you need to kind of make sure your graph is big enough to see the intersection points, please do so. We're good. So all yours, go for it. These 2 are the easy ones though. That's just going to be in quadrant, just quadrant 1, right? you can't have -4 chickens, so we're not going to forget the other quadrants, forget 2, 3, and 4. We're only going to be in quadrant 1. So if that's the case, I don't need to draw all 4 quadrants. I do need to maybe make this one just a bit bigger, so I'm really concentrating. Say again?
They all figured it in 4. Only quadrant would be like above 4. Like 5x and 5y.
Sorry, no, don't get it.
X plus 2y is greater than or equal to 4. So you want the graph to be bigger than 4 units high or 4 units wide.
Oh, yes, True. And I'm going to go probably even, let's see, because there's still a relationship there, right? So I do have to solve. Noah's asking this because there's 4, right? We're going to go 4 units high. I want to solve it, then I can kind of see where I'm going to be. I really need the intersection points. That's what I'm looking for. So how do we graph these guys? We solve for y. So let's go with it here. So I'm going to subtract x from both sides. Oh, how did we do this last time? Because remember we pretended equal. Is that what we did? We said, look, if it is equal to, it would have looked like this. I would have subtracted 4x from both sides. I would have divided by 2. Tell me if you guys agree. Is this my graph right here? So if I start off at 2 and I'm going down by 1/2 each time. Okay. So far, so good. Then I'm gonna have to do this one as well. So this one, pretend equal. I'm going to subtract x from both sides. This time I'm going to have to multiply through by -1. And I need that right there. Are we good? We're graphing these lines and we have to test each line. Cool. Give you guys 30 seconds, go for it here. Can you guys graph the line? Shade, just do this like a light shade, which way it goes. And can you find for me the feasible region? That's what I want. It's a region that holds all these 4 inequalities together. On my graph here, at least looks like I have to go too high on it. I don't know, 3, maybe 4. Maybe I'll go with 4 high because I got to think about where the ends are going to be, right? So if me to get back to 0, this is what I'm kind of thinking here. For me to get back to 0, this would probably have to be a 4. Half of 4 is a 2, -2 plus 2 is 0. So I know along the x-axis for me to hit a 0, I got to be this way. For me to hit the 0, oh, that's easy. This is just 1. Start off at -1 and I climb up to +1. And I'm going to go further still. Yeah, I'm thinking like, let's just do 4. You guys may have to readjust your graphs here. So I'm going to go 1, 2, 3, 4, 1, 2, 3, 4. Okay, dealing with quadrant 1 only. I start off with 2. I go down 1 over 2. Down 1 over 2. Are we good with this line here? Boom. And then we have to pick a test point. Is that right? So we did for 7, 5. Pick a test point. I like 0, 0. Things cancel. Love it. So real quickly, let's go back. If I were to plug in a 0 here and a 0 there, is that true or false? So go back to my original statement is 2x. Oh, I'm sorry, x plus 2y. X plus 2y. Is that less than or equal to 4? Yeah. So that means my shade is going to be this way. And if you want to put like little arrows, that's fine too. If you want to just put a light shade, that's cool too. But here's what I got for this line. Okay, next one. Next one is y is equal to x minus 1. So that means, oh, look at this. I do have to go down a little bit here.
Oh, you could start it at -1.
Sure, absolutely. You could start here. You can start here, whichever way you like. So I'm going to go up 1 over 1. Hey, up 1 over 1. Hey, there's my intersection point. These guys do hit right there. Okay, as I draw this, test point. What do you guys say? 2, 0, 0, 0, whichever. I'm testing x minus y is less than 1. I like 0, 0. Boom. True, false? True, yeah. And so now I have a shade that looks like this right here. It's going to go into here. Awesome. Okay, I'm gonna make my little drawing. So feasible region is right here. Okay, that's based upon 4 inequalities, based upon the fact that I have can't draw outside the lines. Well, you know, I'm gonna see something here real quick here. My eraser is a small eraser. No, I'm still gonna be able to, nah, won't work. Okay. Okay, class, what do you guys say? Good there? Got my region? So now let's list our. Perfect. Okay, boom, this guy is 0, 2. I still have the 0, 0. Here's a corner here. That's the. So then I have this one, which is 1, 0. And then I have my corner, which is 2, 1, is that right?
That's what I thought.
Yeah, 2, 1. I got my 2, 1. Okay, 1, 2, 4 corners here. That's no problem. Let's, Jan, what are we trying to maximize again? 3x plus 2y, right? So go for it. So here's what we're gonna do. We're gonna plug in just 4 times. We're gonna plug in the x and the y. So if we think about raising pigs and chickens, we're thinking about, okay, what would be the most profitable? Let's just go all out with chickens. Let's not raise anything at all. That's 0, 0. Forget that. Or let's just go with pigs. If we raise just 1 pig, again, this could be 1, this could be 1,000,000, right? Just depending what we're looking at our count here. Or we're going to raise a combination of the 2. So I'm not sure how that's going to work, but let's plug them in. Doesn't matter what order. 0, 2, 0, 0. So I'm going to plug in 0, 2. 0, 2 gets plugged in. 3 times 0 plus 2 times 2 gets me. Just 4, huh? 4, that's raising just the chickens. You good? Raising nothing at all, that's pretty easy to know. That's just 0. Not doing it. Boom. Okay. Raising 1 pig or 1,000 pigs. It's 3. And raising a combo of both here. What is it? 2 combo 1. Perfect. Oh, awesome. 3 times 2 plus 2 times 1, 6, 7, 8. And so again, what is my scale here? I don't know my scale. Is my scale in the millions? So I'm looking at $1 million profit, $8 million, $8,000. What am I looking at here? Say again. Correct. Yeah. In a season, and at the same time, and the ratio is 2 to 1. So I'm gonna always have double of my ratio for the other ones. Cool. When I drive to work at college, I pass by a turkey farm, and it's just like rows and rows of turkeys. And right before Thanksgiving, this becomes like so, I mean, there's trucks coming in like all the time. So it's interesting. Okay, let's see. We have enough time for another one. So good. I wanted to go slow just so we're kind of comfortable with it. Is that good, you guys? Graph them. Once you graph them, go from there. Sometimes you have something called an unbounded region. So let's do this one here. Exercise number 2. I think we'll finish up with that one here. This one, because these guys are long. Z is equal to 4x plus 2y. Now, are these guys that simple? No, it isn't, right? Because a profit function is going to have a lot of different things in it too, right? This is just really simplifying stuff. But all yours, can you do this?
You just have to figure it out from that one.
So we're trying to maximize here. You can maximize or minimize. In the book, there's like, this always has to be the case, right? I mean, if we're dealing with really objects, that's going to be true, right? And so we have x plus 2y greater than or equal to 4. We have 3x plus y is greater than or equal to 7. And negative x plus 2y is less than or equal to 7. Okay, all yours. Give you guys 3 minutes. Try it yourself. Go for it. I'll start it as well, but see if you guys can graph it here. Let's see, I see a 7 over here as well. So maybe like 7 out would be pretty good. So again, x is greater than or equal to 0, y is greater than or equal to 0. I'm gonna have to be in quadrant 1. All right, and let's start it as well. Two, 3, 4, 5, 6, 7. 2, 3, 4, 6, 7. And maybe leave a little space because I might have to go actually down here in order to graph stuff. I'm not sure yet. I might have to go very high to graph the other ones. I'm like not sure the way it's going to work here. So let's go back to, okay, you guys try it yourself here. I'm going to start doing mine. Set equal to 4. Subtract. That's what I'm graphing there. Okay, then now let's see, 3x plus y is equal to 7. Let me just solve each of these guys so then I'm kind of ready for graphing here. Negative 3x plus 7. Ding. That's that one. Negative x plus 2y equal to 7. Oh, that's not so fun. It has a fraction inside of here. X plus 7. Negative 1/2 x plus 7/2. Units. Seriously. Okay, again, object is you gotta have to figure out where the corners are, right, on this thing. Okay. I think I'm ready for graphing here. So 2 up 2. Down 1 over 1. I think we had this one before. There's my first line. Oh, off a little bit here. And let's see, I plug in a 0, 0, it's false. So now I'm going to go this way. Okay, that's the first one. Second one is the 7 coming down. Oh man, it's all over here. 7. That's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3 over. 1, 2, 3 over. Oh, it hits right here. That's kind of cool. 1, 2, 3 over. At that point, I don't care about it anymore. I'm gonna go from here. So 3x plus 7. You guys, it's here, hits here, and then keeps on going. And I plug in 0, 0 in my mind. That is a false statement, so it has to be pointing this way. And the last one. Last one is that 3.5. Oh boy, that's no fun. So 1, 2, 3.5. So my starting point is right here. Hopefully I'm going to hit this somewhere nice. So let me go back real quickly here. Start off with 3.5. Because this is 3.5. I'm going to go 1 up, 2 over. So 1 up. I'm at 4.5. 2 over 1. 2. Oh man, that's not looking nice. So I go like this right here. Oh, maybe it is. Maybe it is actually just hits this little guy right here. That's my next. Maybe this was a little higher. Maybe it is 1. Maybe it does hit right here. Guys, 3 minutes left. Say again, Joe. Go ahead. Cool. Okay. So we have a little problem.
It's like barely above it.
It's barely above it. Okay. So let's do this here. I want to just check because now, oh, sorry, real quick here. 0, 0 plugged in, and that is true now. So we'll go like this right here. So everything's down. So I have a feasible region. Let me draw it out, shade it out if you need be here. My feasible region. Whoa, hold on. My feasible region is this one right here. Here it is. It's like this one right here. It's not contained. It's actually not containing. It's well unbounded. It's this little piece, and it keeps on going forever. Oh, bummer. Okay. Let's if you guys hold on real quick. Almost done. Almost done. We have a minute and a half left. So plenty of time to finish up stuff. Okay, real quick here. I need to know whether this guy here is a nice intersection point. I know this one. This one's nice. This was based on the graph. This is 2, 1 right here. This one actually hits at 4, 0. Are we okay with 4, 0 right here? How do I know what this guy is? And what I got to do is I got to plug in. I think it's 1, 4. Let me plug in 1, 4 into the bottom equation. So real quick here, does 1, 4 give me this? So that's the bottom equation. It does. Okay. Does 1, 4 give me this? Oh, cool. Okay. So 1, 4 is actually the correct solution here. We good? Okay. With that said, what's our maximization equation? Anybody? 4x plus 2y. Okay, so what we're going to do is we're going to plug in 1, 4, 2, 1, 4, 0, and you should find out that the answer for this one actually is going to be, how do we maximize it? It's going to be 4, 0. We don't need the pigs. We're just going to go with chickens this time because that would maximize. You guys can check it out yourself. Go for it. You should have an answers of 12, 10, and 16. 16 is the 4, 0 part. So with all the feet involved and everything else like that, the other, we don't need it. Okay, guys, enjoy the rest of your day. And we'll do answers to the logic puzzle on Wednesday. And we have 4, 7, 4, right? 7, 4. Thank you, Hagen. Thank you so much. 7 4 is due at the end of the table over there.
Because I checked my answer papers and we got the same ones. I need to not forget. I'm keeping